Hey everyone, this is Ryan DeGregorio, host of Mind Bending Astronomy. Thanks for joining me and welcome to today's episode. Last time we talked about the imminent collision that our galaxy will have with Andromeda in a few billion years from now. Today, we're going to talk about a really exciting thing that happens in the universe called a supernova. And a supernova is what happens when a massive star explodes. And these events are so energetic that they can outshine entire galaxies. So here's how it happens. Every star has a life cycle. It's born and it lives on the order of billions or sometimes trillions of years, and then it dies. And some stars, like our sun, will just slowly expand and then poof off the outer layers of gas, and we'll be left with a white dwarf, going out with a whimper. But some more massive stars, specifically 8 times the mass of our sun, will go out with a bang. And what happens is that so much matter is being compressed into a confined space that it just ruptures, and all of that energy is released in one giant supernova. There are two ways that a supernova can occur. The first way is something called a 1b supernova, and this is when a really massive star runs out of fuel. Now, massive stars can burn through more heavier elements than just carbon and oxygen. They can burn elements like silicon and iron. And once they get to iron, once they've fused all the elements and is left with iron, the star can no longer fuse iron atoms together to release energy. So what happens is that gravity starts to win the battle against pressure. And pressure is what's keeping the star alive. It's what's keeping it bright and burning. And gravity is now crushing this star into such a small space that the subatomic particles in the star's core can't move any closer together. It's such a packed room that there isn't any more space to occupy. And we can't break physics, so what happens is there's this rebound effect. And it's a really complicated process, and I don't think there's really a clear explanation for why the rebounding happens, but it triggers a supernova and this release of energy that is just cataclysmic. And there's another way that stars can go supernova, and they're called type 1a supernova. And it's what happens when you have a binary system, when you have two stars that are orbiting around each other. And the smaller star, or the more dense star, can pull material from its companion, like a vampire, just sucking out the material from the other star. And it starts accruing mass, and it gets bigger and bigger. And it gets so dense that this little white dwarf star now becomes 1.5 times the mass of our sun, but it's only about tens of miles across. And this is so dense that there's another rebounding effect. So it's the same scenario where subatomic particles are getting squished together so tightly that something has to give, and the supernova erupts. And we're experiencing a massive release of energy. And I'll leave you with this comparison, and it will really give you an idea of how bright a supernova is. If a supernova were to occur at the site of our sun, some 93 million miles away, the light we would see from Earth would be 1 billion times brighter than if you detonated a nuclear warhead on your eyeball a billion times brighter than a bomb pressed against your eyeball. So it's absurdly bright. And the last time we saw a supernova like this with the naked eye, it was probably in 1006 AD, and Chinese astronomers had seen a light in the sky almost as bright as the full moon. But that light was some thousands of light years away. So we may see one in the near future when Antares or Betelgeuse, some red giant stars, explode. And I hope you're there to witness it. Until next time, see you then.